Hello and welcome to this topic, the applications of derivatives. There are various applications for derivatives, not only in math and real life, but also in other fields like science, engineering, physics, etc. In this chapter, you will learn the use of derivatives with respect to mathematical concepts and in real-life scenarios. Derivatives have various important applications in mathematics, such as rate of change of quantity, increasing and decreasing functions, tangent and normal to a curve, minimum and maximum values, Newton's method, and linear approximations. And there are some applications of derivatives in real life, such as to calculate the profit and loss in business using graphs, to check the temperature variations, to determine the speed or distance covered, such as miles per hour, kilometer per hour, etc. Derivatives are used to derive many equations in physics. By solving the application of derivatives problem, the concepts for these applications will be understood in a better manner. A few days ago, I asked my son, Jody, a 13-year-old boy, to draw a picture of space traveler for my calculus. He asked,
"Why do you need the picture of the space traveler in calculus?"
I said, "You see, the derivative came from two problems. One is the instantaneous velocity, and the other one is the slope of tangent line. Imagine a space traveler is traveling in the space along a curve. She finds a beautiful object and wants to move to the object to see it. We know what her traveling curve and the coordinates of the object are. Suppose if she shuts off the engines, she will continue traveling along the tangent line at the point where she is at that time. You follow me? The direction of her velocity is along the tangent line. Can you find at what point should she shut off the engines in order to reach the point?" He said.
I see. It's the problem of tangent line, so we can apply the derivative.
Yes, that's the topic of today. Now let's see one example. This is a picture Jody drawn for me. So this is a space traveler. A space traveler is moving from left to right along the curve y is equal to x squared. When she shuts off the engines, she will continue traveling along the tangent line at the point where she is at that time. So the question is, at what point should she shut off the engines in order to reach the point 4:15? Now let's solve it. Suppose she shut off the engines at the point x0, y0. And we can see that the tangent line to the curve y is x squared at the point x0, y0 is L. Then, to reach the point 4:15 means that the point 4:15 is on the line L. So first, let's find the equation of L. Because y equals x squared, and y prime equals 2x, then y prime x0 is 2x0, right? On the other hand, x0, y0 is also on the curve y is equal to x squared. So the equation of L is y minus x0 squared equals 2x0 times x minus x0. The point 4:15 is on the line L, so we have 15 minus x0 squared equals 2x0 times 4 minus x0. Solving the equation, we can get that x0 equals 3 or x0 equals 5. At x0 equals 5, she would not go to 415 since she is moving left to right. So when x0 is equals 3 and y0 equals 9 is the right point. So she could shut off the engines at 3, 9. Alright, just now we are done with the space traveler problem. Now let's see another problem. Imagine a fly is crawling from left to right along the top of the curve y equals 7 minus x squared. There is a spider with at the point 4, 0. Could you find the distance between the two insects when they first see each other? Now let's analyze it. To find the distance, we need to find the point of the fly. The point where the two insects first see each other means the spider is on the tangent line to the curve. Otherwise, either the spider can't see the fly or that's not the first time. Alright, now let's solve it. Suppose the fly is at the point x0, y0 when it first sees the spider and the tangent line to the curve y equals 7 minus x squared at the point x0, y0 is L. So, first let's find the equation of L. Because y equals 7 minus x squared, y prime equals minus 2x, then y prime x0 is minus 2x0. On the other hand, x0, y0 is also on the curve that y equals 7 minus x squared. So the equation of L is y minus 7 minus x0 squared equals minus 2x0 times x minus x0. The point 4, 0 is on the line L, so we plug in it, the equation still works. Now solving the equation, we get that x0 equals 1 and y0 equals 6. And we can find the distance that the distance is square root of 45. So the point that the fly first sees the spider is 1, 6. And the distance between them 4, 0 and 1, 6 is approximately equal to 6.7. Alright, that's all for this section. I'm looking forward to discussing more applications of calculus with you. That's all for today. Thank you.